Good morning and welcome to the types of chemical reactions. In this video, we will explore how to identify the 5 different types of chemical reactions. The first one is a synthesis reaction. As you notice, you may see it also referred to as a combination reaction. In this case, you are taking 2 or more substances, whether they are pure substances or compounds, and you are creating one product. In a decomposition reaction, think of the word what decomposition means. It means to break something down. So you're starting with one reactant and you're ending up with 2 or more products. A single replacement reaction, notice the name also has the word displacement as a substitution for replacement. In a single replacement reaction, a pure substance, either a pure metal or something that is diatomic, is replacing a metal or something that is a non-metal. Like replaces like. Metals replace metals. Non-metals replace non-metals. In this case, you can have either a cationic single replacement reaction or an anionic single replacement reaction. In a cationic, a metal is replacing a metal. In an anionic, a non-metal is replacing a non-metal. In a double replacement reaction, also known as a displacement reaction, you will have 2 parts of an ionic compound switching places. I usually just say switch the 2 that are positive and rejoin them with the part that is negative, a double replacement. And then a combustion reaction, you are burning something in the presence of oxygen to produce carbon dioxide and water. There are other products in combustion reactions, but these are the 2 that we're going to focus on. Okay, a synthesis reaction. 2 or more substances, they can be pure substances or compounds, creating one compound. Here's an example. You can see that you're combining potassium, which is a pure substance, and chlorine, which is a pure diatomic substance, to produce potassium chloride. Here we're starting with 2 reactants, and we're producing one product. Synthesis reaction. The key is 2 or more reactants producing one product. Here is another example. Sulfur trioxide and water combining to form sulfuric acid. You will have your 2 reactants and one product. Please note that this reaction is not balanced. Please take a moment and balance that. Decomposition reaction. You are starting with one reactant. That reactant may have only 2 elements. It can have 3 elements or more. The key to a decomposition reaction is that you are starting with one reactant and producing 2 or more products. Those products can be pure substances or they can be compounds. You're definitely going to have some sort of energy or heat or catalyst to spur these reactions. Think about it, if you have a glass of water sitting on the table, it's not spontaneously going to decompose into hydrogen and oxygen unless there was some source of electricity or energy provided to that glass of water. So this will not happen spontaneously. You do need that energy or heat. So note that we have one reactant, which is the water, and we have 2 or more products. In this case, they're both pure substances. Another example is decomposing potassium chlorate to produce potassium chloride and oxygen, and this one is balanced for you. One reactant, KClO3, producing 2 products, KCl and oxygen. A single replacement reaction, remember I mentioned that like replaces like, metal replaces metal, and non-metal replaces non-metal. Remember that in an ionic compound, metals are written first, non-metals are written second. So in this case, notice that A replaces B. A has to be a metal for it to be written first in front of C. And then B is going to get bumped out and be all by itself. So that is a cationic single replacement reaction. A must be a metal, replacing B, which also is a metal. Cations are positive and metals produce positive ions. Here we have a halogen, or maybe it's hydrogen. Oh, and keep in mind, hydrogen can act as both a metal and a nonmetal, depending on where it is in the compound. Here we have A, which is most likely it's either hydrogen or a halogen. And notice this time A is going to replace C. So now you're going to get Ba, and then C is going to get bumped out and be all by itself, but in its pure form, most likely it's diatomic. So we're going to have to write it properly. So if A is replacing C, C is negative. A would then be creating an anion, which is a negative ion. So this is called an anionic single replacement reaction. You're always going to have like replacing like. We're not going to get into this too much, but in the first case and in the second case, A has to be more reactive than B in the first one, and A has to be more reactive than C in the second one, or else these reactions will not occur. Just because you can write and balance a chemical equation doesn't mean that that chemical equation can actually occur in nature. Not all reactions can occur. If A2 is, say, bromine and C is fluorine, this reaction would not occur. Fluorine will never get bumped out over any other halogen below it, chlorine, bromine, or iodine. So let's look at some examples. In this case, we're going to have A replacing B, which means that since B is written first, it is our cation, and A must be a metal. So A is going to replace B. B is going to be all by itself on the side. A replaces B. It is written first because it's going to be our positive ion. And then B is going to be written all by itself. It got bumped out. And so this is going to be that cationic single replacement reaction. When we write pure metals, in the case of B being by itself, you're just going to write the chemical formula from the periodic table. So like replaces like. In this case, A is a metal and B is a metal. Metals replace metals. So here we have magnesium, which is our metal. Sometimes that can be hydrogen. Keep in mind, hydrogen can act as both a metal or a nonmetal. In the hydrochloric acid, which is the HCl, hydrogen is acting as a metal in this case. So metal replacing metal. So magnesium is going to replace the hydrogen. Hydrogen is not a true metal, but it's acting as a cation in this situation. So magnesium is going to replace the hydrogen. Hydrogen is going to get bumped out. And when it's written by itself, it is diatomic. It's one of our magic 7. It's one of our diatomic pure elements, so it's going to have to be written as H2. And then the magnesium is going to join with the chlorine, keeping in mind that magnesium is a +2 and chlorine is a -1, switch and drop, so our formula is written as MgCl2. And you do have a 2 in front of the HCl to balance out this particular reaction. So this is going to be a cationic single replacement reaction. Another example we have is with a nonmetal replacing a nonmetal. So in this case, A is going to replace C. Because C is written second, it's going to be our nonmetal. So you're going to have Ba. Since A is going to replace C, C is going to be all by itself, written properly in its pure form. So A is going to now be next to B in the second position, in the anionic position. And then C is going to get bumped out, and most likely C is a halogen, so we need to write it properly as C2. Since A replaced an anion, this is called an anionic single replacement reaction. A nonmetal replacing a nonmetal. Again, keep in mind that also hydrogen can act as a nonmetal or a metal. In the first one, it's acting as a metal. In this case, A is most likely a halogen, and so is C. So here we have chlorine and potassium bromide reacting to form potassium chloride and bromine. So C is our nonmetal. In this case, C is a halogen. And it's going to replace the same type of substance in KBr. Well, potassium is a metal, so it's going to replace the bromine. Bromine is acting as our nonmetal, which is also a halogen in this case. So chlorine bumps out the bromine, and bromine is going to be written all by itself. Since bromine is diatomic, it's going to be written as Br2. Then we're going to combine the potassium and the chlorine, keeping in mind that potassium is a K plus and Cl is a -1. So we're going to write it as KCl. Then we do need to balance that to balance out the bromines and then to balance out the chlorines and the potassiums. So you see a balanced anionic single replacement reaction. A double replacement reaction, in this case we have an ionic compound made of cation A and anion B, and we have another ionic compound made of cation C and anion D. We are going to replace A with C. Like replaces like. So A is going to bond with D, and C is going to bond with B. In this case, in order for this reaction to take place, A and B and CD must be able to be dissolved in water, or else these reactions cannot take place. There are rules to determine if this can happen or not, but again, for our purposes, all of our reactions are going to take place. We will get a precipitate. You've seen those precipitates before during lab. Those are the substances that fall to the bottom of the either the beaker or the spot plate, and those are insoluble in water, and then you'll have one product that is soluble. So we have A and B combining with C and D, ionic compound joining with an ionic compound. So in this case, A is our cation, B is our anion, C is our cation, and D is our anion. Like replaces like. So let's switch A and C. If we switch A and C, A is going to join with D, and C is going to be with B. So we have to, again, write properly our positive ion first and our negative ion second. So our positive ion is A, our negative ion is now D, and our positive ion is going to be C, and our negative ion is B. So this is a double replacement. Our two positive ions switch places, and then we have to rewrite properly AD and CB. So two ionic compounds combining to form two ionic compounds. So here we have a double replacement reaction. Ammonium sulfate and barium nitrate producing ammonium nitrate and barium sulfate. In this case, ammonium is our positive ion, and barium is our positive ion. Those two are going to switch places. The barium is now going to go with the sulfate, and the ammonium is going to combine with the nitrate. So we're going to first look at the ammonium nitrate. So the ammonium is going to go with the nitrate because we have a positive with a negative, keeping in mind that ammonium is a positive ion, a +1, and nitrate is a -1. So we have NaHNO3 as our final formula. And then barium is going to combine with the sulfate, always writing your positive ion first. So barium is a +2, and sulfate is a -2. So BaSO4 is our final formula. And then you can see the balanced equation for this double replacement reaction. We've already looked at combustion reactions a few times. You're always combining a hydrocarbon with oxygen to produce carbon dioxide and water. Just a reminder, a few things is these are going to produce large amounts of energy. They do require oxygen. They're going to involve some sort of hydrocarbon, which means that the first part of the formula is going to have carbon and hydrogen. It could have oxygen and other parts of it as well, but the two true parts are the carbon and the hydrogen. There are other types of combustion reactions, but for our purposes, we're going to focus on the hydrocarbon producing oxygen, combining with oxygen to produce carbon dioxide and water. Some of these that you've heard of are methane, ethane, propane, and butane. And notice the prefixes meth is 1, eth is 2, prop is 3, and but is 4. An example is combining methane gas and oxygen to produce carbon dioxide and water. This is not balanced. We're going to look at balancing in just a moment. So you may see these. You do not have to memorize these. I will provide you with these on the test. So let's look at, everyone go please to in your calendar packet. This refers to page 7. Let's look at the first few on page 7. and check to see if you identified the reaction types properly. So in number 1, you can see that we have sodium and bromine, which sodium is a positive ion, bromine is a negative. So we have an ionic compound combining with phosphoric acid, which is also an ionic compound. So we have sodium as our positive, we have hydrogen as our positive, and those two are going to switch places. The sodium is going to go with the phosphate, and the hydrogen is going to go with the bromine. So now we have a double replacement reaction. In the next one, we have calcium hydroxide and aluminum sulfate. Again, two ionic compounds producing calcium sulfate and aluminum hydroxide, two more ionic compounds. So if you notice in the products, the calcium and the aluminum switched places to produce calcium sulfate and aluminum hydroxide. This is also a double replacement reaction. Please note that on these 7, they are not balanced. You can check balancing in the answer key. In the next one, number 3, we have a switch of magnesium and iron. Notice that the iron is now all by itself. The magnesium bumped out the iron. So this is a single replacement because metal is replacing metal. This is a cationic single replacement reaction. In number 4, notice what we have. We have a hydrocarbon combining with oxygen to produce carbon dioxide and water. Well, the only thing that can be is a combustion reaction. In number 5, we have one reactant, lead-2 sulfate, producing 2 products. One reactant producing 2 products. We're breaking down something, one item, so that is a decomposition reaction. In the next one, notice we have iodine all by itself. We have a pure substance by itself. We also have hydrogen all by itself in the products. So notice what's happening here. We have hydrogen acting as a nonmetal. Iodine is our diatomic nonmetal. Iodine is going to replace the hydrogen. Hydrogen gets bumped out and is written all by itself as an H2. So this is going to be an anionic single replacement reaction. It's a little different than the ones I showed you in the example, but it is an anionic single replacement. And then number 7, notice what we have here. We have water and sulfur trioxide, which means we have 2 reactants producing 1 product. 2 reactants producing 1 product. We're forming 1 substance. That's going to be a synthesis reaction or a combination reaction. Check your answers to numbers 1 through 7, and then also check your answers on pages 7 and go back and check them on 5 and 6 as well. Now they have a better understanding of types of chemical reactions. Now let's just review balancing. Go over to page 10 in your calendar packet. Now the first thing I want you to do is to remember that these don't have all the necessary lines that you're going to need for balancing your reaction. So the first thing I want you to do is just take a moment right now and make a line in front of all of your hydrocarbons so that you don't forget you have to balance those. If you need to stop the video and do that, go ahead and do so. The next thing you're going to do is you're going to combine each of those hydrocarbons with oxygen. You're burning something in the presence of oxygen. So each one of those can be combined with oxygen. Then your products are always going to be the same, carbon dioxide and water. Now keep in mind when you are balancing combustion reactions, you're going to do it in the same order always. You're first going to balance your carbons. So in this case we have 6 carbons. So to balance 6 carbons, we're going to need to I'm going to pause on this slide and I will redo it for you in just a few minutes. At this point, I'm going to end the video and thanks for listening.